On July 8, 2022, the USS Harry S. Truman was conducting routine flight operations in the Mediterranean Sea when the unexpected happened. As the aircraft carrier battled a sudden burst of powerful winds and heavy rain, an FA-18 Super Hornet broke free from the flight deck and slid over the side of the ship. Within seconds, one of the U.S. Navy's most advanced carrier-based fighter jets disappeared beneath the waves. Valued at more than $60 million, the Super Hornet was not simply another aircraft. It carried sophisticated avionics, advanced radar systems, secure communications, and highly classified technology that the Navy could not afford to lose. Although the pilot was not inside the jet, one sailor suffered minor injuries during the incident as deck crews scrambled to respond. Aircraft carriers are built to operate in some of the world's harshest conditions, and strict procedures are designed to prevent exactly this type of accident. The last time a U.S. Navy fighter was lost overboard from an operational aircraft carrier under similar circumstances had been decades earlier, making the incident both rare and deeply concerning. But the aircraft itself was not the only problem. Nearly 9,500 feet below the Mediterranean Sea, a classified fighter jet now rested in complete darkness, beyond the reach of divers and ordinary recovery equipment. Finding the aircraft would become one of the most challenging recovery missions in the U.S. Navy had faced in years. The moment the Super Hornet disappeared beneath the Mediterranean, the mission changed completely. This was no longer about recovering a damaged aircraft. It was about protecting some of the U.S. Navy's most sensitive military technology before anyone else could reach it. Modern fighter jets are packed with classified systems that take decades and billions of dollars to develop. Inside the FA-18 Super Hornet are advanced radar components, secure communication equipment, mission computers, electronic warfare systems, and encrypted software designed to give American pilots an advantage in combat. Even if the aircraft itself could never fly again, the technology inside remained invaluable. If those systems were recovered by a rival nation, engineers could study them, search for vulnerabilities, or attempt to reverse engineer critical technologies. Protecting that information is a matter of national security, which is why the Navy treats every lost aircraft as a race against time. Recovering the wreck would also allow investigators to determine exactly what happened on the flight deck. By examining structural damage, attachment points, and onboard systems, investigators could reconstruct the accident and identify changes needed to prevent a similar incident in the future. But recovering the aircraft would be anything but straightforward. Before they could lift the fighter from the seabed, they first had to find it in one of the most unforgiving environments on Earth, nearly 9,500 feet beneath the surface, where darkness, crushing pressure, and freezing temperatures make even locating the wreck an extraordinary challenge. Recovering the Super Hornet could not begin until the Navy answered one critical question. Where exactly was the aircraft? Although the jet had fallen from the USS Harry S. Truman, the carrier was constantly moving, and the aircraft did not simply sink straight to the seabed. Wind, waves, and underwater currents all influenced where it eventually came to rest. The search began by reconstructing the exact moment of the accident. Investigators analyzed the ship's GPS data, radar logs, weather reports, and the aircraft's last known position. Oceanographers then modeled underwater currents and drift patterns to estimate where the fighter was likely to have settled nearly 9,500 feet below the surface. With the search area established, specialized survey vessels deployed advanced sonar systems to map the seafloor. Multi-beam sonar created a detailed three-dimensional image of the ocean floor, while side-scan sonar scanned wide sections of the seabed, identifying unusual shapes and debris that stood out against the surrounding terrain. Once sonar operators detected a promising target, the Navy deployed autonomous underwater vehicles, AUVs, to collect higher-resolution data before sending remotely operated vehicles, ROVs, equipped with powerful lights and high-definition cameras into the darkness. Guided by pilots aboard the recovery ship, the ROV slowly descended through the black water until the unmistakable silhouette of the missing FA-18 Super Hornet finally emerged from the seabed. The Navy had found its aircraft, but locating the wreck was only half the mission. Lifting a 30,000-pound fighter jet from nearly 9,500 feet beneath the Mediterranean would prove to be an even greater engineering challenge. With the Super Hornet finally located, the most dangerous phase of the mission could begin. Finding the aircraft had been difficult, but recovering it from nearly 9,500 feet below the Mediterranean Sea required a level of engineering few organizations in the world could achieve. The Navy partnered with the multi-purpose vessel MV Everest, a commercial deep-sea salvage ship equipped with a powerful heavy-lift crane and specialized recovery systems. Working around the clock, engineers and salvage experts carefully planned every step of the operation. At that depth, the crushing pressure made it impossible for human divers to reach the wreck, so the entire recovery depended on advanced remotely operated vehicles, or ROVs. Guided by pilots aboard the ship, the ROV descended into complete darkness carrying steel rigging and lifting hardware. Using robotic arms and high-definition cameras, it carefully threaded heavy-duty lifting slings through reinforced sections of the aircraft's structure. Every connection had to be precise. A single failure could send the fighter crashing back to the seabed. Once the rigging was secured, the salvage crew slowly activated the ship's heavy-lift crane. Inch by inch, the Super Hornet began its long ascent through thousands of feet of water. Hours later, the battered aircraft finally broke the surface. Seawater poured from its fuselage as the crane carefully swung the damaged fighter onto the deck, marking the successful completion of one of the Navy's most complex deep-sea recovery operations. But the mission was not over. Recovering the aircraft was only the beginning. The Navy still had to uncover exactly what had gone wrong and ensure it could never happen again. Once the Super Hornet was safely aboard the recovery vessel, the focus shifted from salvage to investigation. The aircraft was transported to a secure military facility where Navy engineers, aviation specialists, and accident investigators began a meticulous examination of every damaged component. Their first priority was protecting and recovering any classified equipment still inside the aircraft. Mission computers, encrypted communication systems, radar components, and electronic warfare hardware were carefully removed and evaluated to ensure no sensitive technology had been compromised during its time on the seabed. Investigators then turned their attention to the aircraft's condition. Despite spending only a few weeks underwater, the Super Hornet had suffered significant structural damage. The immense pressure at nearly 9,500 feet, combined with corrosion from saltwater and the force of the impact, had twisted sections of the airframe and damaged critical systems. Every fracture, attachment point, and broken component helped investigators reconstruct the sequence of events that led to the accident. The findings provided valuable lessons for future carrier operations. From reviewing aircraft securing procedures during severe weather to refining emergency response protocols, every detail was analyzed to reduce the risk of similar incidents. Recovering the aircraft wasn't just about protecting technology. It was about improving safety for the sailors and aviators who operate from America's aircraft carriers every day. But this recovery revealed something even more important about modern naval warfare. To most people, recovering a sunken fighter jet may look like an expensive salvage operation. But for the U.S. Navy, it's something far more important. In modern warfare, information can be just as valuable as firepower. Every aircraft carries years of research, advanced engineering, classified software, and technologies designed to give American forces a decisive advantage. Allowing those systems to fall into the wrong hands is simply not an option. The successful recovery of the FA-18 Super Hornet demonstrated more than the Navy's ability to lift a damaged aircraft from nearly 2 miles beneath the sea. It showcased an extraordinary combination of deep-sea engineering, autonomous robotics, precision planning, and military expertise working together under some of the harshest conditions on Earth. It's a reminder that naval superiority isn't measured only by the ships sailing on the surface, but also by the ability to operate in the unexplored depths below. As technology continues to evolve, protecting military secrets will become just as critical as developing them. Every recovery mission strengthens future operations, improves safety, and ensures that America's most advanced capabilities remain out of reach of potential adversaries. If you enjoyed this deep dive into one of the U.S. Navy's most remarkable recovery missions, subscribe to Carrier Command for more premium documentaries exploring naval warfare, cutting-edge military technology, and the incredible operations that happen beyond the headlines. Thanks for watching, and we'll see you in the next mission.